All right, boys and girls. Here's number 11 from 2-2. This is pretty much a graphing calculator problem in parts A and B, and then a pretty simple part C. Pardon me. So the regression capabilities, this is a really important thing that we don't probably spend enough time on. We have done it in each of your classes, but it's just been a part of each of your class. Think of regression lines as like a very important mathematical skill going in the other direction. So now we have data and we want an equation. It's the opposite of what we typically have, but it's really a more real life problem. So you're going to remember these steps, maybe from Algebra 2 or Algebra 1, but what we're going to do is we're going to go into Stat and we're going to edit our lists. Okay, our lists are blank. First, under L1, I'm going to put our speeds. So 20, 40, 60, and 80. Now, it looks like we have two different things that depend on our speed. There's the reaction time, how quickly we are able to start hitting our brakes, and then there's the braking time, which means once we engage our brakes, how long does it actually take for the car to come to a rest? And then here, we're going to add those up to give us the total time that it takes for us to stop the car. So imagine first, your brain has to react and tell yourself, hit the brakes. And then the car has to react. And the mechanics have to get set into place so that the car actually stops. So over here, I'm going to type in our reaction time. So 9.0, 17.4. Obviously, you got to make sure you type these in right, but I can't tell you how many times I've made a mistake going too fast. 25.7. Okay, and then I'll give it a quick check. See, I already see I did something wrong here. They don't match up. 20, 40, 60, 80. So over here, surprise, surprise, I made a mistake. There's an 100 there. Okay, we're back to good. Checking my work. All right, so now 3, 9.7, 20.9, 36.5, 56.6. Okay, so now what we want to do is this one, they want it to be a linear model. So let's go to stat. Don't worry, they're not going to, and then we want to calculate. Now look, we have a linear regression, a quadratic regression, a cubic, all different types of equations that can be used to best estimate this data. Well, they tell us they want a linear regression, so I want 4. And let's see, we want a linear regression for reaction time. Good. Well, reaction time is L2. So I got to make sure I get that right. And here you'll see the numbers that match up with this. So they're saying, I'm giving it to you in the form y equals ax plus b, which is linear, mx plus b. A is your slope, b is your y-intercept. Bam, there it goes. Okay. So now let me go back to stat and let me calculate. And now we're going to calculate, well, they want a quadratic for b. Now, in this list, I want list 3, which is down here in blue. So I hit second 3. Now it changed to list 3. Uh-oh, did something wrong. Stat, calculate, 5, my bad. L3. Bam, there it is. Okay, all right. So this 0.0557 rounds up to 0.56. You see that? And there you see the 0.74. Now, the total stopping distance, once again, is how long it takes you to react plus how long it takes the car to stop. So all you do, look, you just added these two together. If you notice, 0.417 plus 0.0014 is 0.4814. 0.74 plus 0.68 is 1.42. This is the graph of A, B, and C. Notice you got a line and a parabola, and if you add the line and the parabola, then let's see, I wonder if this is the other parabola. Can't tell. All right, so now the calculus isn't that bad. We just want to take the derivative of this function, okay? So the derivative of t of v is t prime of v, and that is, let's see, 2 times 0.0056 v to the first, and then plus 0.4184, okay? So let's see if we got that right. I think I got on, unfortunately. Like, get out of this, scroll down, and there you go. Okay. So then to find the rates of change for these distance. So what is that? What are we finding? Well, so it's change in distance over change in time. All right. So as you can see, the faster we're going, the higher our rate of change. So because like if we slam on our brakes when we're going to 100, the deceleration is going to happen faster in terms of change in speed and change in time. That doesn't mean we will get stopped faster. And then so look, for increasing speeds, the total stopping distance increases, which makes total sense. Okay? All right. Hope this helps. Have a great day. I gotta get out of here. Uh-oh.